we're getting close to the end of the chapter. So, I know next week on Wednesday, it's that virtual learning day because the seniors and the freshmen will be taking the P.7a and the SAT on that day. So on Wednesday, you guys aren't coming into the building, but it's considered a virtual learning day. So you guys will have an assignment to do online that day. Right? So when it comes to your attendance, remember how there's that little link on there for you guys to do attendance? So since you're not in the building, you'll click on that attendance link for you guys to do attendance that day. Remember doing that back in the day? Right? So yeah, so that's on Wednesday. So then I think it'll be, so like next week we'll just have regular instruction on Monday, Tuesday, Thursday, and Friday. Then that following week, I think on Tuesday we'll have like the chapter test, if everything plays out. Sound like a plan? I think that's what I had. I'll double check, but yeah. Sound like a plan, Stans? All right. So we get to jump up to our P7. And P7 is looking at equations and being able to solve equations. Oh, I think, okay. Work on that later. So everything, like earlier, we were just looking at expressions because the only thing we were able to do was to simplify whatever it was that they gave us. So now, with an equation, the difference between an equation and an expression is an equation has a equal sign. Yep, good job. So since we have that equal sign, we can actually like solve for our little variable, right? So let's say we have a crazy little linear equation. Linear means it would actually make a, starts with an L, a line, okay. And we want to solve. So let's say we wanted to solve 2x minus 3 in parentheses minus 17 equals, making it an equation, 13 minus 3x plus 2. Does that look like fun? Anybody got any ideas what we might want to do first? Use that little distributive property. All right. So we're going to take our 2 and we're going to distribute it to everybody that's inside the parentheses. And then on the other side, we're going to take that negative 3 and we're going to share it with everybody, right? So what do we end up with? 2x minus 6 minus 17 equals 13 minus 3x minus 6. You guys agree with me so far? Yep. And then now we're just going to kind of plug and chug until we can get it all simplified, right? So what are we going to end up with? 2x minus 23 equals negative 3x plus 7. Okay. So then our ultimate goal when we want to solve something is we want to get that variable all by itself. So for us, we want to get our x all by itself. And don't you guys all want your x's to be all by themselves? That was a joke, guys. Ha ha ha, you're so funny, Mrs. Fitch. You make me laugh every day in class. Tough crowd, tough crowd. All right. So, I don't know. You want to add 3x to both sides? Yeah, I like that idea, right? So then we have, what, 5x minus 23 equals 7. And you can do multiple steps if you're comfortable with that. And what are we going to do? Add 23 to both sides. 5x equals 30. Is your x all alone yet? No, he's still got 5 friends with him, right? So we got to get rid of those friends. So we're going to do it. Divide by 5, both sides. We do it to one side, we got to do it to the other. 5 over 5 is 1. So it's going to leave us with x equals 6. And we know that we're solved because our variable is all by itself, right? X is all alone. Not too shabs? You good with those ones? Any questions, comments, concerns? Ooh, that's too light, isn't it? Alright, I'll stick with the colors I have. So we might as well spice it up a little bit then, right? We like spicy. You guys like fractions? Fractions are your friend. So let's say we decided to get all fancy today, and we have x plus 2 over 4 minus x minus 1 over 3, and that whole thing equals 2. Anybody's heart starting to sink yet? Getting heart palpitations? Right. So fractions are your friends, and fractions aren't bad. They're nice little guys. They treat you well. Right? They help your grade out, right? Because if it wasn't for fractions, we'd only have like whole numbers, and you know, you'd either get a 0 or a 1 or 100%, and that's, you got to have some in-betweenness. So that's where our fractions come in. So respect the fraction. So anytime you guys have a fraction and you don't like the fraction, you can always get rid of fractions. So I'm going to look at my denominator. So I have 4, 3, and technically there's a 1, but he's just there. If I look at my denominators and I find my common denominator, and if I go through and multiply everything by a common denominator, I can get rid of my fractions. Bless you. So what's our common denominator going to be? 12? So I want to go through and multiply everything by 12. So I'm going to multiply this whole entire side by 12. So x plus 2 over 4 minus 12 times x minus 1 over 3 equals 12 times 2. So now when I look at my little fraction right here, oops, that's really bad. Gotta go wide. That 12 over 4, what's 12 over 4? 3, right? So, blah. This is gonna cancel to be 3. And if I just look here, 12 over 3 is gonna cancel and be, what's that simplify to? To 4, right? So I'm just going to write it out the long way. So then technically I have 3 times x plus 2 minus 4 times x minus 1 equals that 12 times 2. Okay. So now we're kind of right back to where we were on that first problem, right? We're going to use our distributive property. 3x plus 6 minus 4x plus 4 equals 24. And I bet you guys could finish the problem before I could. You ready to race? Go! Did you guys beat me? Man, you guys are good. Did you guys get x equals negative 14? Yeah. See, fractions aren't bad. And then just to write another problem, we don't have to go through and actually work it all out unless you want to. Because on this problem, like we didn't have a fraction over here. Well, we do, right? It's technically 2 over 1. But you can get it to where the whole, every component is a fraction. Let's say we had 5 over 14 minus x plus 5 over 7, right? So now when it comes to finding my common denominator, I'm looking at all of these numbers. So between 4, 14, and 7, what's my common denominator going to be? 28? Yeah. So then you're going to go through and you're going to multiply each piece of these by like 28, right? And then simplify it and keep going from there. You guys good on that next step of what we're doing? I'm going to hold you to it. All right. So you guys are going to have some fun with some fractions? Yes? Yes. Yep. Yep. So we got some fractions, and then your other favorite, you want to do some absolute values? Absolutely. See? And I know we briefly talked about absolute values earlier this year, right? You guys remember the definition of absolute value? Distance from 0. Yep. So after we take that absolute value of whatever we have, you know, it's always got to be a positive number right at the very end, because distance is always going to be positive, right? So we're going to do some solving of some absolute values. So let's say we have 5 and then an absolute value 1 minus 4x, closing up the absolute values, minus 15 equals 0. So on these ones, our rule of thumb, you want to be able to isolate that absolute value before you take the absolute value. So we want to isolate the absolute value. So in other words, we want to get everything on the other side of the equal sign except for just that absolute value part. So think of it kind of like, I mean, in a sense, think of this whole entire thing. If this was just x and you wanted to solve for x, you would add 15 to both sides and then you would divide by 5, right? So we're going to do the same thing, but we're just going to leave our absolute values for right now. So we're going to add 15 to both sides. So we have 5, the absolute value of 1 minus 4x. And that's going to equal 15. And then we want to divide both sides by 5. 5 over 5 is 1. So now we have the absolute value of 1 minus 4x equals 3. So now that we have our absolute value isolated all by itself, because we know when it comes to taking that absolute value, we're looking for that distance from 0. So this stuff in here, like it could equal 3, because then the absolute value of 3 is 3. Or this stuff in here could equal negative 3, because then the absolute value of negative 3 is going to give us 3. So once you get the absolute value all by itself and it's isolated on the one side, that's when you're going to split it into two equations. And we're going to have either 1 minus 4x equals 3 or 1 minus 4x equals negative 3. So then what are we going to do? Subtract 1, so negative 4x equals 2. Divide by negative 4, and we're going to get x equals negative half. And the other equation, we're going to subtract 1, so we're going to get negative 4x equals negative 4, and then x equals 1. So when it comes to this little x equals negative 1, our little x in here, whatever we solve for the variable, our variable can be negative, right? Because if we put in that negative half into here, we get 3. Granted, this guy can't equal a negative number though, right? Because you can't take the absolute value of it, making it equal a negative number. So if you guys had to do a cheesy problem, let's say we had the absolute value of x plus 4 plus 6 equals 3. So this one's a you try. Yes. Oh. So the first thing you did was subtract 6. Yep. Then you get the absolute value of x plus 4 equals negative 3. Right? And then what'd you notice? You can't take an absolute value and make it equal negative 3, right? Because what do we know about absolute values? It's that distance. So whatever that distance is, it has to equal a positive value. So this would be, anybody got any idea what we want to call it? I think I heard everybody say it. Yeah, no solution. Right. So they'll always try and trick you on those ones because you get in the habit of just like, oh, if it's absolute value, it's got to equal, positive, negative, and then you kind of keep going. So we got to pay attention to our little equations because sometimes they like to be a little tricky and try to tell us that absolute values equal a negative number, and we know that they don't. Sound like a plan? And then tomorrow we'll just go over a couple. Do a little bit on quadratics. We've already factored the quadratics, so now we're just going to make them equal something and solve those, and then do a little refresher on that quadratic formula, and then you'll have the rest of the time to work on some problems. Not too shabs? Oh, I forgot.